150 Yale?
Yep.
Okay, and does that look like everyone on the screen is from your team? Does that look right?
Yep, that is correct.
Great. All right, perfect. And we're all here. We're not missing anyone?
No, I think we have everyone.
Okay, great. Okay, thank you. So I'm your Q&A judge. However, this is getting recorded, so we'll be able to review it with other judges later as well. So I did get a chance to look at your video. It looks like you guys had to scale back quite a bit. You had originally planned a 2-stage
30,000 rocket.
An SRAD 30,000, right? And we scaled it back to 1-stage COTS.
Yep.
And
10,000.
10,000, okay. And how far did we get on that build? Yeah,
so all the body tubes have been made, and we have like the motor mount tubes, and we have parts of the nose cone, we have the E-bay, and all the parts for the engineering bay, the altimeter and stuff like that, but we haven't been able to start any of the assembly. So we also have all the parachutes, so we have all the individual parts made except for the carbon fiber nose cone. We have the mold for it, but we haven't laid it up yet. And so making the assembly is basically the main thing left.
Okay, and are you planning on completing that? Are you wanting to work on that?
Yep. So we probably will not be able to work on it this summer, but we plan on working and finishing it next year.
Okay. Are you going to work it into next year's? Are you hoping to launch it next year, or are you using it as sort of a test launch?
I think we'll see how the test launch goes. We want to launch it first, and then if it goes well, we can improve on it. So it kind of depends. So yeah.
And did you get to do any component testing of the parachute?
Yeah, so the parachutes have already been tested, as some of these parachutes have been flown in prior years and have been recovered. And so we have the same parachutes that will work for this specific rocket. And so the parachutes do work.
Okay. Let's see. Tell me a little bit about your fins. You use carbon fiber fins?
Yeah, so we have someone that's not on call right now that worked a lot on the fins. And so she worked with software, I can't remember the exact name of it, but to do flutter analysis and designing the shape. And they're made out of carbon fiber plate. And so they're cut with water jet, and then the edges, are sanded down. And so it's carbon fiber plate, but then the body tubes are made of carbon fiber, except for obviously the sections with electronics that have fiberglass.
Okay, and how are you attaching the fins? Are you just using like a resin to attach carbon fiber to carbon fiber on the body, or?
No, so basically the motor mount tube obviously is going to have couplers, couplers around it. And those couplers are going to have slots. And so the body tube also has slots. And so we're slotting the fins into well, they're basically like they're like bulkheads, but like donut shaped, obviously. Mm-hmm. And so they're slotting into both the rocket and those bulkheads. And we made a jig to hold the fin stable while we basically epoxy it all together. So it will still be epoxy, but the fins are also slotted into the rocket to allow for a stronger stability and stronger attachment.
Okay, so it's still an epoxy attachment, but so no bolts or hardware or anything like that. Okay.
No.
All right. And then can you tell me a little bit about the electronics bay?
Yeah, Yuhang, I don't know if you want to talk about that a little bit.
Yeah. So this year we designed a modular electronics space from ground up. I only joined like around like the beginning of this year, and I think it started last year. But from what I've seen from CAD, it uses a kind of like starting design. So everything, so we kind of have like two kind of like drawer size. So we have in the middle section where we have all the actual electronic components, and we'll be able to after like mounting the two kind of the guide rails in the rocket, we can just easy change out any component in the center part if you want to, and easy make modifications because everything is modular. So that's what the baseline for the year, and besides that, I think that's what we have to for eBay that I can remember.
Okay.
Yeah, so it's 3D printed and modular, and so it allows for easy switching out of the eBay in case any part needs to be switched or when we arm the vehicle or anything like that.
And what material are you using for 3D printing?
It's started like resin. It's resin printed.
Resin printed. So it's okay. So it's not like PLA or PET.
No, it's not PLA or PETG. It's resin printed, yeah. Because like we don't want any support material because we have holes in the middle, and that would be difficult, and some sections that would be difficult to print to allow for all the different parts of the electronics to fit in there and the wires.
Okay.
And so we're doing resin printer, which is a technique that does not need support material during the print.
How heavy is that? How much does that kind of contribute to the mass?
It's actually just as heavy as PLA approximately. The density is about the same.
Even without the because usually, you know, when you 3D print with PLA, you've got sort of an empty honeycomb on the inside, right? So it sounded like it's more of a solid body print than a honeycombed.
So our first print had support material and was done with PLA, and it honestly like felt about the same weight. I didn't weigh the two separately, but it felt about the same weight, like each of them. So the weight is about the same.
Right. Let's see what else. What have you? How have you taken into consideration the weather requirements that New Mexico desert poses?
In terms of the heat and wind, or also the altitude?
In terms of insulation on the body for the electronics, or you know, thermal expansion of the materials, things like this. Like how have you taken into design consideration?
So I mean, obviously, like I can start with the altitude. And so in terms of altitude, obviously during our simulations, we include altitude in there as the base starting altitude, because obviously the density of the air is lower starting off, and so that will obviously mean the rocket will go higher up based on that. And then in terms of thermal expansion, we did not do much design. We did not have much design consideration around that. To the best of my knowledge, carbon fiber doesn't like expand that much under heat, and so it shouldn't matter too much.
Do you have a lot of aluminum parts?
We only have the nose cone that's about this big. That's aluminum, and like most likely we can paint it white to reflect off heat.
And the aluminum nose cone, how does that bolted? How is that affixed to the carbon fiber nose cone? Yeah,
so currently the mold stops obviously before the nose cone would fit, and so this carbon fiber nose cone is going to come up and almost close up at the top, and so the aluminum nose cone tip has two parts, and so the two parts can screw into each other, like basically sandwiching the carbon fiber nose cone.
I think I remember seeing that. So it uses the angle of the nose cone to sort of stop the inside puck because it's curved. and then they're bolted
Yes.
together. What are you just what kind of bolt are you using, or washer, or what on the inside?
It's basically like a screw that, it's like one whole screw, without a head that like screws in, and then we will put like epoxy, obviously, for the edges to seal as well.
Great, that sounds good. How are we in time? We've got a few more minutes. Is there anything that you want me to know about your rocket that we haven't already covered?
Austin, I don't know if you want to talk a little bit maybe about the body tubes or something like that.
Yeah, so for the body tubes, we started off with our coupler, which was just regular blue tube, and we decided it was a good idea that we can use that as kind of like the mold to form our body tube, because the coupler would fit right in, right? So we put like a non-stick layer, and then put one sleeve of carbon fiber, put epoxy on it, and then put the third one, and that's kind of how we kind of layered it, and we're able to form our body tubes.
Yeah, they looked really nice in the video. They looked really good, very, very consistent. I did notice that. I made note of that.
Yeah.
Cool. Anything else? I feel like I haven't heard from this side of the of the room. Anything that you
guys... I mean, I will say this isn't too specific to the rocket, but just because of COVID, membership this year has been really difficult. So yeah. I'm somewhat of a refugee from our CubeSat team who's just trying to kind of help. So I was helping with the open rocket simulations, but I think as much as, like you've heard from Guillaume a lot, I think it's been a really small team this year, and that's made it difficult just with, navigating all the restrictions that Yale put on us.
Are you all going to be on the team next year, or is this some of you graduating?
Yeah, we're going to be on the team.
Excellent.
Next year. And so, so I was obviously project leader this year, and next year Austin will be taking on the project leader role. And Ryan, that's also in the school, is going to start a division to try and do some research around a liquid engine and trying to build just a liquid engine standalone. And so this is probably going to be, 1 or 2 year project, obviously, because a lot of research has to be done with EHS. But this is separate, obviously.
Hybrid or biprop?
Haven't decided yet. We're very much it's in its infancy right now. It would be interesting to see if we could just go full on liquid propellant, but hybrid is something we're definitely considering. But there's a lot to look into, of course.
Is that a 2-year R&D?
Yeah.
Yeah.
So I think the focus is like next year, kind of like what Guillaume said. Austin is going to help lead kind of like the main project, which is getting this rocket that we're presenting now flight ready for next year to compete. But during that process, I'm going to try to basically design and hopefully create and test a liquid propellant engine. And then if that's successful this year, then trying to see if we can actually build a liquid propellant rocket around that engine. I have a lot to learn, but that's kind of the goal. So next year we want to compete with this rocket, and then hopefully in 2 years, 2 or 3 years, we can have a liquid propellant rocket.
Great. Thank you so much, everyone. You guys have a great rest of the competition. Go check out some of the breakout sessions. And really appreciate all your hard work this year.